Welcome back to another math video. Today we'll be going through problem number 3 from the 2007 Ap Calc Ab test. Okay, so looking at this problem, we're given a table with the values of the differentiable, thus continuous function f and g. We are also given values for their derivatives. We are then told there's a function h given by h of x equals f of g of x minus 6. Now for the first problem, we're asked to explain why there is a value r for 1 is less than r is less than 3, such that h of r equals negative 5. This is a pretty blatant IVT problem since we're asked to prove that there's a number on an interval which gives you negative 5. Since the problem tells us f and g are differentiable, thus continuous, we know that h is continuous since it's comprised of those functions f and g, and thus we can use IVT. Since we know our value r is between 1 and 3, let's begin by testing the values of h for h of 1 and h of 3. We can find h of 1 and h of 3 by plugging in 1 and 3 into the equation given. However, it's important to note that this is potentially tricky since there's a function inside a function, so that requires a little bit of thinking. But we can easily find values on the table for g of 1 and f of 2 and g of 3 and f of 4. By evaluating, we find that h of 1 equals 3 and h of 3 equals 7. We can then say, since h of 3 is equal to negative 7, which is less than 5, which is less than h of 1, which equals 3, and h is continuous, by the intermediate value theorem, there exists a value r between 1 and 3 such that h of r equals negative 5. Now this answer makes sense because if on the graph h of 1 is equal to 3 and h of 3 is equal to negative 7, and the graph is continuous, there is some point on the graph at which the graph goes through negative 5. So for some value of r on this interval, the graph must pass through negative 5. When this problem is graded, they want to see work finding h of 1 and h of 3, and then they want a conclusion using IVT that shows that the function is continuous and that IVT can be applied, and shows your values for h and 1 of h and 3 that shows that h of r is negative 5. For part B, we must explain why there must be a value c between 1 and 3 such that h prime of c is equal to negative 5. This is structured very similarly to the last problem, except now we're considering the derivative, so we must use MVT. MVT basically states if a function is continuous and differentiable on an interval, there's a value for the derivative which is equal to the slope of the secant line. So to begin solving this problem using the mean value theorem, we must begin by finding the slope of the secant line. Using the slope formula in the table we're given, we see that the secant line has a slope of negative 5. Now to show that we can use the mean value theorem on this problem, we must know that h is continuous and differentiable, which we do know since f and g are both differentiable, thus continuous. We can then say, since h is continuous and differentiable, by the mean value theorem there exists a value c between 1 and 3 such that h prime of c equals negative 5. Full points are earned on this problem by showing work finding the slope of the secant line and by writing a full conclusion using the mean value theorem that shows that h is continuous and differentiable. Moving on to part C, we're asked to find w prime of 3 given that w of x equals the integral from 1 to g of x of f of t dt. Let's begin by finding the derivative of w of x. By the fundamental theorem of calculus, when we take the derivative and the antiderivative or integral cancel out, and so we replace g of x into t and then multiply it by g prime of x since the chain rule is used. Doing that, we see that w prime of x equals f of g of x times g prime of x. Don't forget to use the chain rule. Using our table of values, we can evaluate the problem to find that w prime of 3 equals negative 2. Full points are earned on this problem by using the chain rule when taking the derivative and by achieving negative 2 as your final answer. Finally, moving on to part D, we're asked to find the line tangent to y equals g inverse of x at x equals 2, where g inverse of x is the inverse of g of x. So since we know that inverse functions swap x's and y's with the original function, that means that g inverse of 2 is equal to some value, and if we plug that value back into g, we'll get 2. So to find g inverse of 2, we should look at our table and find where g is equal to 2. And now seeing this, we can see that g is equal to 2 when x equals 1. So using that logic, we find that g inverse of 2 equals 1. So to solve this problem, you must know the formula for finding the derivative of inverse functions. This formula is that the derivative of g inverse of x equals 1 over g prime of g inverse of x. We want to find the derivative of g inverse of x at x equals 2, so to solve that, we just simply plug x equals 2 into this equation. Doing so, we find that the derivative of g inverse of 2 equals 1/5. However, part D is asking for the line tangent to the graph at that point. So now we must plug this slope and the point 2, 1 on g inverse of x into our equation for lines to find the tangent. Doing so, we find the b value is 3/5, so the line tangent to g inverse of x at x equals 2 is y equals 1/5 x plus 3/5. Full points are earned on this problem by finding g inverse of 2, by finding 1/5, or the derivative of g inverse of 2, and by finding the tangent line equation. Thank you for watching my video. If you need extra practice, I have links in the description providing extra IVT, MVT, chain rule, and inverse function problems below. Thanks for watching!